Welcome to part 4. We're starting part 4 today, the same day I finished part 3. But in between time, I replaced all the capacitors. Now I want to make a note here. I don't know what happened, but about 3/4 the way through the part 3 video, 3/4, maybe a little better than that, all of a sudden the audio went loud and distorted, crackly and distorted. And I'm using the JVC. That's what I'm using now, and I used the JVC in part 3 also. So I hope I'm not having trouble with the cameras. There's no audio adjustment that I can find in the JVC camcorder. So hopefully it won't do it again. And I was not talking loud. I'm talking about 6 inches away from the camcorder now, which of course, as you know, has a flip-out screen. So we'll see what happens. I replaced the capacitors, my hook and pinch method. I had one hell of a time doing it, but I did it off camera, of course. It took me several hours just to do these here. I tested some of the resistors. They seem to be okay. I didn't test all of them. I replaced these. This is a 100 volt 001, I think. Not sure. Brand new. So you don't need anything more than that for the volume control. It happens to be that I have it in my supply. I replaced this capacitor, and I'm in the process of replacing the capacitor off of the audio output tube plate, which is pin 8 of the 35, I got to get over here, 35L6. It calls for a 0005 or 0.0005 or 0.00047. I happen to have a bunch of different values that I got. I don't know, maybe at Jewett City one time, I don't know. They're 500 volt or 600 volt rated. They look like silver mica. So it's some kind of a bypass cap, and I'll show you on the schematic where it is. It's a cathode bypass. So why would they use such a small value in that? I don't know. I got to turn this off. Not ready to solder yet. It's right here off the cathode of the 35L6. I can't point because I'm holding the camera and I'm holding the schematic. And I cannot read that. I think it's, I can't even begin to guess what the number is. But down here, there is a 0.0005 capacitor. I cannot see that. I needed a lot of magnification, but I did find it. The print isn't all that good on this. So it goes from the cathode to a resistor, and like I say, I don't know where B- is on this thing. I really don't know. It's a very confusing circuit. But anyways, that's the capacitor I'm replacing. And this was in there. I don't know if it's upside down. I really can't tell. In fact, I better take a magnifying glass and look at this. I'll be right back. Yes, it's a 0.005. So I looked it up on the computer, and it's a 500 picofarad, which is exactly what this is. I also have 470 picofarads, but we're going to replace it with this. I think this is a silver mica, but it's not really needed in there, but that should work in here. So we're going to put that in. I'll be right back. It's in there. I'm not proud of my work, but I can't do any better than that. If I had to go right to the tube socket, I would fail completely. So hook and pinch is the only way I can do it. I'll give you a look at the rest of the radio here. Alright, we've got a cap right here, the big one with the bubbles on it, closest to the camera. That might be the across the line capacitor. I got a safety cap for that. I think it's an 05. And there's one down behind it on the bottom. Cathode, I don't know, because usually the cathode bypass is an electrolytic and it's quite large. But that would probably be this big vertical resistor here, and I can't read it right there. I think that's the cathode resistor, but it goes down to the first horizontal line. So like I say, I can't find common negative on this. I think I made a notation over here. C7 and C8 are filter caps. So I think that's a filter cap. That's a filter cap, and I found out that there's a notation here that this particular radio uses a choke instead of the speaker field, and it's down here. I don't know what my chassis is. It's 6A08 or 6 or something. I can't read that. So I think it's 60A8. Chassis uses choke to replace field coil. So there's no numbers indicating what chassis I have. So what I do, and as I've always said, especially this is original, if it's an 05, I replace it with an 047. If it's an 01 or a 001, I replace it with a 001. Whatever the resistor is, I replace it with the same. So we really don't need the schematic unless a part is missing or been replaced or miswired. So you can see that that schematic is quite difficult to read with the what resistor number and what capacitor number and so forth. But anyways, we'll get back. We're going to work on these two here later on in this video, but I gotta finish what I'm doing in the house. So we'll be back. Don't go away. We have more to do. Off the plate of the 35Z5, pin number 5, I believe it is, we have a 25 ohm resistor. That's what I measured, and I think that's right here. The problem is, this is very hard to read. It's blotchy. So I'm having a hard time seeing what the values are and the C and the R numbers, designations of what they are, like here. And here, I put a plus here because I take it that that's the choke. It's supposed to be the field coil, but this model uses a choke, so it's probably wired the same. So I'm taking that this and this here are the filter caps. I think okay, so the plus would be over on this side for this one. I didn't mark it. So that would be the 20 microfarads. And there's the electrolytic. And what I want to do, I'm going to try to saw off the electrolytic with it in the chassis. I have a small hacksaw. It's going to be real messy, but I think I can do it. And leave everything in there and connect it there. Obviously the B minus is the negatives of the electrolytic. But trying to find it on the schematic, because it's not clear, it's not marked really good. So that's what we got to work with. For my own records, that's a 0.05. That's the line cap. It goes from pin 2 of the 35Z5, where one side of the line cord comes in, and it appears to go to the can of the electrolytic, but it's very, very difficult to get in there. I need to snip that off, but I certainly don't want to lose my place in this, because I can't get at that other cap behind it until I do that. Well, the switch I don't think is any good. It's reading 13.8 ohms. Turn it off. Turn it back on. Now it's 22 ohms. I think it is. I can't see there's an indication up there, but I can't tell what it is. It's all over the place. Turn it off. Let me just, I can't get close. Oh, it's so awkward working here. All right, the switch is off. The switch is on. The switch is off. Switch is on. It's all over the place. I'm going to try to get WD deoxide in here. I don't know if I can. We'll give it a try off camera. I got the other cap in right here. It's a 0.01. So we got pretty much access to the electrolytic. This is where the line cord goes. You can probably see that better than me. It looks like, I can't tell. Red and yellow wire. And then to the top right, there's a stub sticking out, a stub. I gotta take the camera light away. I can't do both. Right here, that is where I clipped off the cap, the 0.05 across the line cap. So we got a notation down here so we don't lose our place. Alright, I sprayed deoxide and turned it back and forth there and click, click, click about a dozen times here. So it's off right now. So let's put you on the meter here and I'm going to turn it on. Half an ohm, that's good. Turn it off. Turn it on. Half ohm. Turn it off. Turn it on. 0.7 ohms. It's close enough. Turn it off. Turn it back on. 0.5. Off. On. Takes a little while for this meter to respond. Off. On. Good. Okay, the switch, apparently this wire, I can't really trace it out. Probably goes to the common negative. So you're switching the ground, which we're not going to do. The line cord comes in here. This is a piece of it right here. I always leave it on so I know where it goes. So we put a polarized cord and plug on here. Originally I said I wasn't going to do it because I couldn't find, it didn't seem to make any difference, but I don't know, maybe it's better that I do that anyways. And switch, leave the let's see, put this on the neutral, take off this wire, wherever this goes, I'll have to trace it out, and it shouldn't be too hard now that I got those caps out of here. And switch this lead, which is supposed to be the hot lead at all times. So that will switch. So there'll be a wire running from this pin to the switch and then back. So that's what we'll do, but we're not doing that now. What I want to do here is try to not disturb those terminals that are on the bottom there. I want to saw the electrolytic off on the chassis. I think I can do that if I saw it a little above the bottom flange. In other words, I was originally going to cut it off at the top, but that means more work in getting that stuff out of there. If I cut it, I'm going to have to use my fingers. I don't have a pointer handy by. Right where my fingernail is, right there. Okay. If I saw it in the chassis, and what I'll do is I'll take some masking tape, I've got enough of it, and just put it down in here, okay, and cover this whole area up and cover up the tube sockets with masking tape. Take the chassis outside and hack it off so to get this piece out, and then whatever tar is in there, it's only going to be about a 1/4 inch of tar at the most. I should be able to work that out of there and make connections to those terminals. Matter of fact, I might cut this up maybe 3/8 of an inch from the, I'm off camera again, from the here to probably about here. I'll hack it off, because we're not going to use that electrolytic. We're not even going to fire this thing up until we get the 2 new caps installed. Okay, folks, this is the end of part number 4. I'm having a heck of a time reading this schematic here, a really, really hard time. The problem is, and I'm not going to keep hashing it, you know I got bad eyesight, so I really sound stupid on it. On the last video, part 3, the one that's just up there. Anyways, I was having a hell of a time trying to find common negative. It's very hard because of the schematic is not clear at all. And I don't know, all these online schematics are like that. So I'm going to end this. This is the end of part number 4. I got the electrolytic to do. It's getting dark now. It's 6:15, so it's time to end it all. And I'll saw that electrolytic off after I do what I said I was going to do on the chassis here. But the part listing, the parts list is virtually impossible to see. It just globs. You can't tell what's R1, R2, and you know, you can just barely see it, and you have to count down like C1, but then you can't, well, C1 is the tuning condenser and stuff like that, and then the one after that. Some of them you can read, most of them you can't, and it's really difficult. I'm trying to go by the schematic and trying to trace it out. The obvious thing I want to make very clear, and I should have on the video before this, is the common negative is your negative of the electrolytics. But trying to trace it out in that rat's nest, because you can't move wires around because it's rubber coated. So anyways, we're ending this. I think the next part, I'm not positive, maybe sawing the electrolytic off and trying to clean out the tar on the part that I leave on the chassis. This way I won't have to disturb any of that rubber coating wire that's connected to the electrolytic terminals on the bottom of the electrolytic. The new caps will be soldered to the studs, and I'm hoping there are studs coming up through the tar that I'll be able to solder to. That's another story. Otherwise, I'll be forced to do a Mickey Mouse job on it. And I don't like that. It's bad enough that I have to hook and pinch. I've always done that, but my work is extremely sloppy now because of these. That's it, folks. That's the end of part number 4.